Hello everyone, myself Dr. Ruchira Goel from Department of Applied Science and Humanities, Ajay Kumar Garg, Engineering College, Ghaziabad. Today I will be teaching Mathematics 4, code KAS 302/402. The topic is Statistical Techniques 3. In this content, I will be discussing chi-square test, goodness of fit test and test of independence. Now let us discuss chi-square test. Chi-square affords a measure of correspondence between theory and observation. So if OI, where I goes from 1 to up to n, that means n observations are there, is the set of observed frequencies, and EI, again I is taken for 1 to up to n number of values, that means expected frequencies are also n in number, the same as that of observed frequencies. So this is the corresponding set of expected, or we can say theoretical frequencies. Then chi-square is given by this formula. Chi-square is equal to summation is taken over all the values. That means if we are taking n items, then I goes from 1 to up to n. This is OI minus EI whole square in the numerator divided by EI in the denominator. So we will first of all find this value of OI minus EI. We will take its square divided by EI, the expected frequency, and thereafter the summation is taken over all the values of I. So we can simply write this formula also instead of the instead of writing I going from 1 to n. It is understood that I is taking all the values starting from 1 till n. The condition is OI sigma must be equal to EI summation. That means sum of the expected frequencies must be equal to sum of observed frequencies and must be equal to the total frequency. If this condition is fulfilled, then only we can apply the chi-square test. Degree of freedom is given by n minus 1 for a one-way test. If it is a two-way test, then degree of freedom in that situation is given by number of rows minus 1 into number of columns minus 1. We will elaborate it further in coming slides. Now these are some of the applications of chi-square. So chi-square test is one of the simplest and the most general test known. It is applicable to a very large number of problems in practice. So that's why this is of so much importance. Now chi-square is used as a goodness of fit test. That means the given distribution, what we are fitting, what the data is given, that is good enough or not. And chi-square is also used as a test of independence of attributes, whether the attributes of two datas which is given to us are independent of each other or not. It is also used as a test of homogeneity of independent estimates of the population variance. This means that there are many population variance available to us, and whether all the population variance are homogeneous in nature, that can be checked from with the help of chi-square test. Now degree of freedom for binomial, some of the theoretical distributions are for binomial it is n minus 1, number of observations minus 1, for Poisson it is n minus 2, for normal it is n minus 3. So if we are required to fit these distributions, then chi-square is a very good test to be used for checking the goodness of fit. So chi-square test basically enables us to ascertain how well the theoretical distributions means Poisson, binomial and normal, they fit the empirical distributions. So whatever theoretical values we are having by calculation, actual values will come out to be nearby, or whether the distribution which we are fitting is good enough to be fitted or not, that we can check with the help of chi-square. Now if chi-square, how to check that? So to check it, we will check whether chi-square which is being calculated, its value is less than chi-square which is given by the table. Then chi-square calculated, if it is less than the tabulated value of chi-square, then fit is considered to be good. And if chi-square calculated is greater than chi-square tabulated, then fit is considered to be poor, so we will reject that fit. So here it is also important to take into consideration the degree of freedom. So for a certain degree of freedom, we can look up the table of chi-square tabulated, and we can see whether chi-square tabulated is actually coming out to be more or less than the chi-square calculated value. If it is more, it will be good to fit that distribution. If it is less, then it will be not good enough, we will reject that particular distribution. Now chi-square as a test of independence. So with the help of chi-square, we can find whether or not two attributes are associated. For example, we are taking the variance or we are taking the mean. So these are the attributes of the distribution. So whether these two, whether the attributes of two particular data sets we are taking are related or not, we can find that. So for that, applying for chi-square, we always need null hypothesis H0. H0 is considered as, suppose there is no association between the attributes under study. So suppose we have taken this as a null hypothesis. So we assume that the two attributes are independent. Always when we considered H0, we will consider that the attributes which are given are independent. It depends on the question whether the data set is giving us the attributes as dependent or independent. So the sample data set out into two-way table called contingency table is being studied in this particular topic today. So for that, to make that contingency table, first of all we will require expected frequency in each cell. So to calculate EI of each cell, what we will do, we will write down product of column total with row total divided by grand total. So this is the way in which we will calculate expected frequency of the contingency table. Now let us elaborate it with the help of an example. So from the following table regarding color of eyes of father and son, we have to test if the color of son's eye is associated with that of the father's eye. So this is the value which is given to us. We are given the color of and not light, and color of son as light and not light. So this is the data 471, 51, 148 and 230. It is given that tabulated value of chi-square at 5% level of significance and degree of freedom 1 is 3.814. That means chi-square tabulated at 5% degree of freedom 1 is 3.841. So this is given to us. Degree of freedom is 1. This is given. So with this value we have to check our calculated value of chi-square. So let us consider first of all the null hypothesis. So obviously we will consider that there is no association between color of son's eye with that of father's eye. Okay, father's eyes. So that means the color of son's eye is independent of the color of father's eye. So for H0, we first calculate EI in each cell with the formula column total into row total divided by grand total. And then we will calculate chi square by the formula chi square equal to sigma I equal to 1 to n OI minus EI whole square divided by EI. So what we need? We need EI first of all. So to calculate EI, since if we have a look at the table which was given to us, this is 471 plus 51. The total comes out to be, this is row total. So we are left with 522. Then 148 and 230. The total comes out to be 378. Okay. Then we will take column total also. So this is 9619. This is 281. So grand total comes out to be 900. So now we have a look at the first value. So first row total is 619 into 522. This was the value. Let me just show you. This is 522 was the row total, 619 was the column total, divided by grand total is 900. So this is 619 into 522 divided by 900, which comes out to be 359.02. The second column was having total as 281 into 522 was the row total. Then we are having divided by 900, which is coming out to be 162.98. Then in the first row and in the first column and second row, 378 was the total of the row, 619 was the total of the column. Multiply these two divided by this total of 900. So we are having 259.98. Then 378, because we are having second column and we are taking the second row, so that's why second row, second column. So 378 and 281, these two values will be considered. These will be multiplied into these will be divided by the grand total 900, which gives us 118.02. So this side we have row total, this is our grand total, and this is our column total. So this way we proceed, and after finding EI, we'll write them in the tabulated form as this was OI for all the 4 rows and columns we have written. Corresponding to each of them we have written EI, and we have taken the value OI minus EI whole square divided by EI. So this comes out to be 34.927, 76.939, 48.232 and 106.249. What we have done, we have subtracted these two values correspondingly in each row, then taken their squares, and then we have divided by the EI respectively to get the value of the last row. So chi-square value calculated is taken sum of all the values. So we have taken sum of 34.927, then 76.939, 48.232 and 106.249 to find chi-square value as 266.347. Now this value we have to compare with the tabulated value which was given to us. If you remember, tabulated value of chi-square was given to be 3.841. Now for this we need to find the degree of freedom also. Now to find degree of freedom, the formula is row minus 1. So there were 2 rows and there were 2 columns. So column minus 1. So this is 2 minus 1 into 2 minus 1. So this is equal to 1. So degree of freedom is 1. So at degree of freedom 1, if we compare this value with this value, this is quite large. So since this is larger, the calculated value of chi-square is larger than the tabulated value. So as per our process, null hypothesis is rejected. So that means the two attributes are associated with each other. That means the color of the son's eye and father's eye are associated with each other. Because this was our null hypothesis, we have considered that there is no association between color of son's eye and father's eye, but we have achieved that there is an association. There is an association. They are associated with each other. So let us consider one more example. So to test the effectiveness, so this is example number 2. So to test the effectiveness of inculation against cholera, the following table was obtained. Now we are given a table in which the number of inculcated patients who are attacked by cholera was 30. Inculcated patients who were not attacked by cholera was 160, and not inculcated patients who were attacked was 140. Then not inculcated patients and they were not attacked was 460. So this was the tabulated values which were given to us. If we see the total of these inculcated, these row wise and column wise, so 30 plus 160 comes out to be 190, 140 plus 460 comes out to be 600, 170 plus 620 comes out to be 790. So in any situation we are having this 30 plus 140 as 170 and 160 plus 460 as 620. So column total is given, row total is given and grand total is given. This is our grand total. 790 is the grand total. What we have to do, these figures represent number of persons. So we have to use chi-square to defend or refute the statement that inculcation prevents attack from cholera. So we will consider a null hypothesis from the statement itself. What we require to check is what we use as our null hypothesis. That means in this question, since we are required to check whether inculcation prevents attack from cholera or not, so this will be our null hypothesis that inculation does not prevent attack from cholera. Okay. So let us consider the expected frequencies. So this expected frequency table or the contingency table, what we call it as, this is our contingency table that we have made. So first of all, let us find out. So first value is 190 into 170 divided by 790. So this is 190 into 170 divided by 790, which comes out to be 40.886. For the next value, we will consider first row and second column. So we will consider 190 into 620 divided by 790. So 190 into 620 divided by 790. Let me just check once. Yeah, it's correct. Then for this particular EI For this we will consider 600 into 170, 600 into 170 divided by 790. And for the last one, we will consider 600 into 620. So this is equal to 600 into 620 divided by 790. Let me just check all the values. First one is first row, first column, 190 into 170, then 190 into 620. Okay, fine. And then 600 into 170 and 600 into 620. Okay, and they are all divided by the grand total. So we got 40.886 as the expected value in the first row, first column, 149.11 as the expected value in the first row, second column, then 129.11 as the expected value in second row, first column, and 470.89 as the expected value in second row, second column. Now with the help of these EIs, we will make the table of OI and EI. So the table of OI is given to us 30, 160, 140 and 460 is given to us. So this is given to us for OI. Now we will consider the table for EI. So table for EI is 40.886 corresponding to 30, 149.11 corresponding to 160, 129.11 corresponding to 140, 470.89 corresponding to 460. So we have OI minus EI square divided by EI value as 2.898, then 0.795, then 0.918 and in the end 0.252. We will add this plus this plus this then plus this to find the value of chi-square. So since chi-square formula is summation OI minus EI whole square divided by EI. So we will add all the values in all the 4 columns in the last row. After adding, we get the value of chi-square calculated as 4.863. Now 4.863 is the calculated value. Now to calculate degree of freedom, we will consider row minus 1 into column minus 1. So since number of rows was 2, so this is 2 minus 1 and number of columns is again 2. So this is 2 minus 1. So it comes out to be equal to 1. Hence the degree of freedom is 1. So at 1 degree of freedom, the tabulated value at 5% level of significance, we always consider without loss of generality the level of significance as 5. If it is given specifically as some other level of significance, then it's fine, we will change our level of significance. Otherwise, always for all numerical problems, the level of significance is considered as 5%. So chi-square tabulated is given to be 3.841. So we can see that this value is actually smaller as compared to the calculated value. So that's why null hypothesis is rejected. And as soon as it is rejected, we will defend the statement that inoculation does prevent attack from cholera, because null hypothesis previously was it does not prevent attack from cholera, and this is rejected. That means it does prevent attack from cholera. So if we inoculate, the cholera attack will be prevented. So that's why we can see that chi-square is considered as a very good methodology to check the attribute values and to consider the fitness of the data which we are considering and to compare them, and hence it is a very good test of fitness. Thank you.